All right, in the last video, we talked about the multiplicity of the factors in a function. That allowed us to see when we go to graph that polynomial, whether it was bouncing or going through at the polynomial's zeros. Today, we're going to start investigating what's going on with the ends of the function, or end behavior. And to start that out, I want you to graph some familiar functions. So if we look at this, I want you to graph x squared, negative x squared, x cubed, and negative x cubed. If you don't remember how to graph these two right here, remember that you can make an xy chart if you need to. Go back to that. Put in 0, 1, 2, and negative 1, negative 2. That should be enough to give you or remind you the general shape of x cubed and then negative x cubed there. So pause the video and graph those. All right, I take it that you've had the chance to try to graph those four. Let's switch over, take a look at them, and see if you got those answers correct. So looking at this, you should have x squared down by now. And if you look at our transformation of the negative in the front, it's going to flip it, and negative x squared looks like this. If you're not familiar with graphing x cubed, remember you could substitute in a few x values like negative 2 through positive 2. And that would give you negative 2, n goes into negative 2, out spits a negative 8. Negative 1 gives us negative 1 again for the output. 0 put in gives us 0 for the output. 1 gives us 1, and positive 2 gives us positive 8. So it looks like this right here. Putting a negative in front flips all of our outcomes, and so we get a flip graph that looks like this. If you know how to do these four functions, how to graph them, then you can use what you know about these four functions to help you understand the end behavior of other polynomials. Let me explain. Going back at this, notice a few things here. One, from right here, let's compare our left end behavior and our right end behavior. So our left end behavior, I'm going to mark in lavender right here. On our left end, the polynomial is going upwards. See that on the left end? On the left end over here, the polynomial is going downwards when we graph it. Right here, left end is also going downwards. On the left end right here, it is going upwards. Now let's mark our right end behavior. Our right end behavior, I'm going to mark in red. So on the right end right here, we're going up. On the right end over here, we're also going up. On the right end right here, we are going down. And on the right end over here, we are also going down. Now, I want you to pause the video and look at that end behavior, and specifically, I want you to start off with the right end behavior. What do you think determines the right end behavior, whether it's going up or down? Pause the video and see what you get there. All right, I take it that you paused the video and you gave that a solid attempt. Let's look back at this. Notice the top two equations, the right end behavior is the same. They're both going up. The bottom two equations, they're the same. They're both going down. And so when we're looking at this right here, we can determine that, what's going on with the actual equation that's making these go up or down? And if you guessed, hey, that negative that made it flip, that is what's causing it to go down on the right end, you are correct, all right? So if it's positive, then the right end behavior goes up. That's that a value into our general form of the polynomial. So if that value up front, that leading coefficient is positive, right end goes up. If it's negative out front, then the right end's going to go down. And notice this happens with both of them. Doesn't matter if we're talking about x cubed or x squared. And later we're going to look at, in fact, let's look at it now, x to the fourth. All right. So let's switch over to Desmos. And if we type in x to the fourth power, notice that both ends in this one are going up, but the right end is going up, and that's what we're focused on right now. If I make this negative, the right end goes down. It really doesn't matter what the degree of the function is. If I say 70 right here, oh, that went to the subscript. Let's go superscript and type in 70. Notice it cannot affect it. That power, whatever it's raised to, does not affect whether the right end goes up or down. Now, if I make it 71, then right end still goes down. Make it 72, right end goes down. Let's make it 6, right end goes down. 4, right end goes down. It doesn't matter what we raise it to. The right end goes down because of that negative out front. If I make it -5, right end still goes down. Now, if I make it positive, boom, the right end over here is going up. So that right end of the polynomial is all determined whether the leading coefficient is positive or negative. Positive goes up, negative, it goes down. Now, with that being said, let's go and see if we can find a pattern going with the left end. So look back at these these 4 graphs right here. The left end is matching the right end there. Down here, the left end matches the right end. So with our x squared and negative x squared, the left side is just taking the lead from the right side and doing whatever it's being told to do there. What about on x cubed? These two ends do not match up. But notice down here, they don't match up again. So the left side of our page here, we're doing x squared and negative x squared. They both follow the same direction there. For it raised to the power of 3, though, they go opposite ends. Let's look over at Desmos and see if there's any pattern going on here. So in Desmos, I'm actually going to take this and let's just look at, let's make that a variable here and add a slider. And once again, we don't want the decimals in here, so I'm going to do a step by 1. And we're going to go from 2 to 92. Doesn't really matter what your max is. We're not going to look at all of them. But if I switch between 4 and 5, notice the end behavior. Really, specifically just the left end. I'm going to leave the right end going up on all of them. Remember, if we make this right here a positive number, 6, 7, 1, whatever, because it's positive, the right end's going to go up every time. But as we look at this, notice as we make that a value switch between odd and even, it's messing with the left end behavior here. If it's odd, it's going to be opposite of this. Notice if I flip this and make the right side go down. All I got to do is put a negative in. Now the right side goes down. But because it's raised to an odd number, 11, the left side is going to go opposite. If I change it to a 12, it matches up here. All right, the end behavior is the same for both. It begins in negative infinity, it ends in negative infinity. So that's the key here. If it's raised to an even exponent, it's going to be the same as the right side. If it's raised to an odd exponent, it's going to be the opposite of the right side. That, once again, is worth writing down. Let's take a look at that. So going back to the right end behavior, remember, the right end behavior is determined by the positive or the negative in front of the leading coefficient. So if we've got a positive in front of that leading coefficient, then the right end is going to be going up. If we got a negative in front of that leading coefficient, then the right end, remember this is right end right here, is going to be going downward. Now, the left end behavior is from the odd even degree. Remember, there is a difference between whether a function has an odd or even degree and whether the function is odd or even. So we talked there, I have a video on odd even functions. Look that up. That's something totally different. We're just talking about the degree. The highest exponent is the highest exponent, odd or even. If that highest exponent is odd, then it is going to be opposite of the right end behavior. So this is opposite right end. If the function is got an even degree, then it's going to be the same as the right hand, or matches. And so this is why I say it's helpful to have those 4 functions that we originally graphed in mind. Let me show you how I use that. So if I were a student taking this in the beginning, what I would do to help me remember when I go to a quiz or a test is I would sketch out those 4 graphs. I would say, okay, Here's x squared. Here is x cubed. Negative x squared, I know, flips it like this. And then negative x cubed flips it like this. Those are the four you need to know. And now I can look at this and quickly see that if I've got a positive, the right end is going to be going upwards. And if it's negative, the right end goes down. And then remember that, hey, look, these match up. So the left end also goes up. These match up, so the left end goes down. Oh, that tells me that if it's raised to an even power, they match. Here I've got the right end already marked. The left end is going opposite. Right end goes down. Oh, the left end is going upwards. So I can see that they're opposite once again. So that little trick helps me remember it so that when I take on harder problems, we know whether the function is going the same as the right end or, the opposite of the right end or the same as the right end. All right, so let's take a look and see what those four functions can do for us as far as helping us figure out the end behavior on these three functions that are a lot more complicated. So as I look at this, I don't know if you can tell or not, but this is actually x to the fifth right here, minus 3x squared plus 7x minus 1. The 5 got a little smudge there, writing it in marker. But now what I want to know is, what is the end behavior of this function right here? Knowing the end behavior is going to be the first step into graphing something that looks like that right there. So the degree is 5, and this leading coefficient here is a positive 1. So the right end is going to be going upwards, because remember, if it's positive, then we determine the right end first. The right end is going to be going upwards. The odd or even of the degree determines what goes on with the left end. And in this case, since it's odd, that degree is, it's going to be doing opposite of that right end. So it's going to be going down. If we look at this on Desmos, I've got these three here to graph. Notice graphing it, the right end goes up, the left end is opposite. Hey, that's a good sign. We got that one right. Now, as far as graphing the rest of it, don't worry about that right now. And even when we do graph it, we're not going to be that specific, but there'll be things that I want you to graph for sure when we go graphing polynomials. For right now, we're just concerned about end behavior. Look at the next one here. The negative part tells me that the right end goes downward. The degree of the function is even, which tells me that it must match the right end. So the left end also goes downward. So in all of these, determine the right end first, just by looking, is that leading coefficient positive or negative? Positive, right end goes up. Negative, the right end goes downwards. Then you can look at the degree and say, is the degree of the function odd or even? If it's odd, it does opposite of the right end. And if it's even, it matches the right end. Okay? Let's look at this one actually graphed. So if we go back to Desmos, and I'm going to turn off that last graph we had here, let's look at this one. Now, when we go to graph this, you might be like, I don't see it anywhere. Let's actually zoom out. And if we zoom out, we notice that the right end goes down, the left end matches it, and that matches what we predicted. Let's go back here. It matches what we predicted right here. The right and left end both go down. One more here. If the leading coefficient is not 1, it's actually, and not negative 1, it's negative 5, the number really doesn't matter. Yes, that does affect the graph, but as far as end behavior, it doesn't affect it. And it's negative. So that means the right end goes down. The degree of the function is odd. That means the left end does opposite. Let's go back to Desmos and graph that. And this one kind of has like a squiggle to it. Notice that the left end is going up, the right end is going down. That matches up. And one more thing I want you to take note of when you look at these, I threw on some extra junk at the end. Notice that all of this did not affect the end behavior. All of this does not affect the end behavior. And all of this right here does not affect the end behavior. So sometimes that messes with people. They feel like that should be, it does affect the function, but it doesn't affect the end behavior. The end behavior is found on that first term here when you have it in standard form with the degree, the degree of the function right there, the highest exponents right there. So use those tricks to figure out the right end first, and then determine the left end to figure out what's going on at the ends of a function. I hope this helped you determine the end behavior of a polynomial function. If you have any questions, please ask me, and I'll see you next time.